Have you ever looked up at the night sky and wondered about that faint, distant point of light, just barely visible to the naked eye? Well, that's Uranus, the seventh planet from our Sun, and trust me, it's one of the weirdest and most fascinating worlds in our entire solar system. Today, we're taking a deep dive into this icy giant, a planet that spins on its side, has rings darker than charcoal, and whether that's truly out of this world. So buckle up, because our journey to Uranus starts right now. First, let's get the pronunciation right. While it can be a source of endless jokes, scientists typically say Uranus. It's a fitting name for a planet that looks like a serene, pale blue dot against the black canvas of space. Now, what makes Uranus so special? Let's start with its most bizarre feature, its tilt. Imagine all the other planets spinning like tops as they orbit the Sun. Earth is tilted about 23.5 degrees, which gives us our seasons. Mars is similar, but Uranus, it's knocked over completely on its side, tilted at a staggering 98 degrees. This means it essentially rolls around the Sun like a ball. Scientists believe that billions of years ago, a massive object, maybe the size of Earth, slammed into Uranus and tipped it over. This extreme tilt leads to the most extreme seasons in the solar system. For 21 years, one pole is bathed in constant sunlight, while the other is plunged into a 2-decade-long winter of total darkness. Then, as the planet continues its 84-year orbit, the situation slowly reverses. Can you imagine a day that lasts for 21 years, followed by a night of the same length? It's absolutely wild. Being the seventh planet from the Sun, Uranus is incredibly far away. On average, it's about 2.9 billion kilometers, or 1.8 billion miles, from us. Light from the Sun takes about 2 hours and 40 minutes to reach Uranus, compared to just 8 minutes for Earth. This vast distance means it's also incredibly cold. Uranus is an ice giant, a category it shares with its neighbor, Neptune. Its atmosphere is a frigid mix of hydrogen, helium, and a little bit of methane. It's this methane gas that gives Uranus its beautiful blue-green color. Methane absorbs the red light from the Sun and reflects the blue light back into space. So when you see those stunning images from spacecraft, you're looking at the effect of methane in its upper atmosphere. But don't let its calm, uniform appearance fool you. Beneath that hazy blue-green layer, Uranus is a dynamic and stormy world. Temperatures in its upper atmosphere can drop to a bone-chilling -224 degrees Celsius. Or -371 degrees Fahrenheit, making it the coldest planet in the solar system, even colder than Neptune, which is farther from the Sun. Scientists are still trying to figure out why Uranus is so cold and doesn't radiate much internal heat like the other gas giants. Below its atmosphere, Uranus doesn't have a solid surface like Earth. Instead, its atmosphere gets denser and denser, transitioning into a hot, dense, slushy fluid of ices, materials like water, methane, and ammonia. At the very center, there's likely a small, rocky core about the size of Earth. We've only had one up-close look at Uranus. In 1986, the Voyager 2 spacecraft flew by the planet, giving us our first detailed images and data. It was a fleeting visit, but it revolutionized our understanding of this distant world. Voyager 2 discovered 10 new moons, 2 new rings, and a powerful magnetic field that's just as weird as the planet's tilt. The magnetic field is not centered in the middle of the planet and is tilted about 60 degrees from its axis of rotation. This means the magnetic field wobbles and tumbles as the planet spins, creating a complex and chaotic magnetosphere. If you could see it, it would look like a tangled, corkscrewing mess trailing behind the planet. Let's talk about those rings and moons. Saturn is famous for its bright, icy rings, but Uranus has its own ring system too. They are just much harder to see. Uranus has 13 known rings, and unlike Saturn's, they are incredibly dark and narrow. The particles that make up the rings are thought to be as dark as coal, which is why they were only discovered in 1977 when the planet passed in front of a star, and astronomers noticed the star's light dimming multiple times before and after Uranus itself blocked it. These dark rings are likely made of rock and ice that has been darkened by radiation over billions of years. And then there are the moons. Uranus is a mini solar system in itself, with at least 27 known moons. The 5 largest are Miranda, Ariel, Umbriel, Titania, and Oberon. They are all named after characters from the works of William Shakespeare and Alexander Pope, a unique naming tradition in our solar system. These moons are fascinating worlds of their own, mostly made of ice and rock. The most intriguing one might be Miranda. Voyager 2's images of Miranda showed a jumbled, chaotic surface with giant canyons, terraced layers, and a mishmash of old and new terrain. It looks like the moon was shattered into pieces and then haphazardly reassembled. One theory is that a massive impact in its past caused this bizarre geology. Ariel is the brightest and possibly the youngest surfaced of Uranus's major moons, with fewer craters and long valleys suggesting geological activity. In contrast, Umbriel is the darkest and appears very old and heavily cratered, showing little sign of past activity. Titania and Oberon, the 2 largest Uranian moons, are also heavily cratered, but show evidence of large faults and canyons, hinting at some internal forces that shaped their surfaces long ago. So, with all this strangeness, what's next for Uranus? For decades, it's been a bit of a forgotten planet, with all the attention going to Mars, Jupiter, and Saturn. But that's starting to change. Scientists are pushing for a new mission, a dedicated orbiter and atmospheric probe to Uranus. A mission like this could finally answer some of our biggest questions. Why is Uranus tilted on its side? Why is it so cold? What is its internal structure really like? How does its weird magnetic field work? And what secrets are hidden on its fascinating moons? Studying ice giants like Uranus and Neptune is crucial because they might be the most common type of planet in our galaxy. By understanding how Uranus formed and evolved, we can learn more about the thousands of exoplanets being discovered around other stars. Uranus isn't just a weirdo. It's a key piece of the puzzle in understanding planetary formation across the cosmos. So the next time you hear a joke about its name, you can share just how incredibly cool and mysterious Uranus really is. It's a planet that challenges our expectations, a world of extremes with a sideways spin, a tangled magnetic field, dark rings, and a collection of bizarre moons. It's a reminder that our solar system is filled with wonders that we are only just beginning to explore. The story of Uranus is far from over, and its biggest secrets are still waiting to be discovered. Thanks for joining me on this incredible journey to the seventh planet from the Sun. If you enjoyed this cosmic adventure, don't forget to hit that like button, subscribe, and ring the bell so you won't miss our next exploration into the great unknown. Let me know in the comments which planet you'd like to visit next. Until then, keep looking up.